Hello everyone, this is going to be an overview of the GrowthNodes add-on. I apologize in advance for the sound of the birds. Can't do much about it. Um, the main purpose of GrowthNodes is exploring growth processes on the surface of meshes. So GrowthNodes is not really concerned with volume. And basically does most of the operation by displacing the surface of an object. If you are interested in volumetric approaches to growth, there is actually an experimental branch available on GitHub, which has a few additional features that goes well beyond what Blender's Python API offers. These include GPU computer reaction diffusion using OpenGL, 2D, 3D textures. 3D textures are also computed using OpenGL and frame buffers. Lots of Python optimization, as well as a dedicated geometry engine, fully written from scratch in Python, which does not utilize Blender's Mesh API. And because of that, there's a huge performance boost when you use that specific engine. However, it does not have many of the functionalities that the regular add-on offers. What we are going over is going to be the simplified version of the add-on. However, it is still powerful. These are some of the images that have been generated with the regular version of the add-on. The reason why I do not maintain or suggest messing around with the experimental branch is that it requires compilation, it requires some external Python modules. It's pretty hacky in order to get some of the OpenGL stuff working, and all in all, it's a lot of headache if you are not familiar with coding and compiling and all that stuff. It took 3 months to develop this project. The master branch primarily has all the features that I've contributed to because I'm familiar with those and it's much easier to develop and maintain. So GrowthNode's been inspired by the Wanderers. This is a project by MIT's Media Lab's Media Matter group in collaboration with Descriptive. And in their video, they're actually doing a lot more that is possible with growth nodes. In particular, for instance, in this scenario, they have some growth happening on curves. If you are interested in projects similar to what you see on the screen, I would highly suggest to also look into nervous systems' ongoing efforts in simulating and digitizing organic growth processes. In terms of installation, this is like any other Blender add-on. I'm not going to go too deep into it. Just download the zip from GitHub, go into Blender, and let's see, in your add-on section, install the add-on from the file, and it should show up under the nodes section, or just look up GrowthNodes over here. The master branch has been tested, however, we're not still 100% confident in its functionality, so be cautious while you use it. And with that, we're gonna get into the actual meat of what is possible with GrowthNodes. So GrowthNodes is going to be accessible from the node editor, which you can access using Shift and F3, or you could just click in any of these regions and select the node editor. In the left panel, there are going to be different sections regarding the data that we are going to be using in our node tree or simulation process. The bake properties section is going to be available for all node trees, regardless if they're empty or not. Over here we have some control on our frame limits. In this scenario, we're saying that the simulation is going to start from frame 1, it's going to go all the way to frame 10. We are able to play it back in both directions, reversed and forward. This allows us to go to set the playback. So essentially, these two buttons will take you to the beginning and the end of simulation without changing the range. If you click on this button, it will actually set the beginning and end of your animation to be that of the simulation. So for instance, if I change the end to be 50 and if I set the beginning to be at 10, I'm gonna set the beginning of my animation to be 10, and as you can see right now we pretty much only have one frame. That's because in the previous setting 10 was where our simulation would end. And now we have set the end to be at frame 50. This slider just allows us to go back and forth to a specific frame. The purpose of this is that you don't go back and forth between the node editor and timeline and whatnot, which is also the primary focus of these two sections as well. However, these two sections, texture data and object data, are going to be populated when you actually start adding nodes. So object data will find all the meshes that you are referencing in your node tree, and texture data is going to reference all the textures that you're using in your node tree. So the way GrowthNodes work is that you select an object or multiple objects, and you select different textures, and there are a few different nodes that allow you to manipulate the geometry and have control over animation. Let's see. So let's start by referencing our object. So let's select simple 001. Alright, perfect. Still, nothing is showing up here, and that is for a reason. As you can see, the node itself also has this dark red background, and this background color is basically indicating that this node is not going to be used in the simulation because it's really not connected to anything. So just to show you what I mean by that, let's bring a texture here as well. Let's set the texture to be clouds twirl, and also let's add a displace node from the geometry section. So far all of these nodes are essentially inactive. However, once I start connecting them, you can see that the background goes away. The texture node is still dark red, and that's because we're not using it yet. As I connect it to my displaced node, now we can see that all of these nodes are active and participating in our simulation. Also in the displaced node, for any of these nodes, what I could do essentially is to just use the displaced node and only select the object that I want. There's a small bug here, and that's because since displaced node is not connected to anything, we're not actually gonna be computing the simulation. So for now, even though we could easily just select the texture from this drop-down menu directly in the displaced node, let's not do that, and let's connect a texture node that is essentially doing the same. If I change my object or any of my textures, you could see that it is directly reflected in this displaced node. Let's go back to what we had. Now you might wonder, what are these textures? These textures are essentially um, Blender internal textures. And what do we mean by that is that they're not the same textures that you would use in Cycle's materials. These are different textures that usually hook up into the modifiers or the particle system, or in Blender internal. They just help with your materials, world, and whatnot. If you want to create one of these textures, you could just go to Blender Render, um, and click on the world, and then click on the texture, and you could just click on the world button, and in one of these textures you could just create a new one. We could do clouds texture, and let's just call it tutorial test just for now. Alright, back to the texture, to the node panel. As you can see, now that we have an object in our scene, object data and animation is actually populated. These buttons just help organization, only to make things easy to read and follow, depending on your own preferences. Show list will show you all the objects that are in your scene. So for instance, if I duplicate this object and also have frame dependent, now you can see that frame dependent is selected. The reason why simple does not show up here, that is because it is not participating in the simulation process. So as you can see, the background is red. Let's go back to simple. Let me delete that. The shape key section is going to be populated usually if the object has shape keys. So in this scenario, I'm going to go back to my shape key sections. I'm going to add a shape key, and now you can see we have different shape keys showing up. So this shape key section, this panel that you have access to, it is essentially a direct copy of what you would find inside your object data panel, or tab, I should say. Texture data is also very similar. There are two options. I can toggle the preview over here. This is a bug with Blender's API and their UI element for displaying textures. So unfortunately, at the moment, it's not possible to preview a texture or multiple textures. Essentially, you could only have one preview. So if you want to see what the texture looks like, just click on Enable Preview. It goes away from there. And if you toggle Preview inside the panel on the left, all your previews from the node editor are going to be temporarily disabled. Let me remove these shape keys before we continue. So inside the texture data panel, we have access to a few different things. We can control texture settings. So if I go back to our tutorial test again, I guess I need to reconnect it. Yep. There's still some small bugs. Like I said, this has not been fully bug-proofed and tested. But they're primarily UI bugs. It's nothing that's going to introduce severe malfunction in how the add-on works. Anyways, so if you remember, for the tutorial test texture, we selected clouds. If I toggle the preview, I can change that to Musgrave. Again, this is the bug that I was talking about, so there are some problems with the texture preview. I can change that to ocean. or I guess ocean is not a good one to use. Maybe noise. Yeah, and anyways, this section pretty much just gives you control over your texture, um, the ramp, the color settings, and all in all, it is essentially what you are going to see in the texture tab showing up here. And this was a conscious decision so that you don't have to go back and forth between these areas. If you need to manipulate something, you can do it most of the times pretty much from the node editor itself. If it's more advanced, or if you need to animate something, for instance a texture parameter, you could do it from the left panel. If you're not familiar with how to toggle these things, for the left panel it's going to be T, or you could select on this small plus button, and usually N is for the right panel, but GrowthNodes does not really add anything to this right panel. So anyways, let's keep this on, and with that, let's go ahead and make our very first test of what we are going to be capable of doing with this add-on. So I'm going to change my settings back to Cloud Twirl. Let's make the start of our simulation to be frame 1, and let's make the end of our simulation to be frame 10. I'm gonna just set it to be the entirety of our animation. Or actually, no, that's not a good idea, because I want to show you one of the cool features of the add-on. This is a plane that I have. It's nothing really interesting, but it's been subdivided a lot to give it some geometry so that we can play with. GrowthNodes is capable of I would say a rudimentary dynamic topology. So you could actually start with a mesh that does not have much detail and keep adding to it as you go on. But in this scenario, since we want to start from the very basic, let's go ahead and make sure that we have some geometry. Or actually, I should say a lot of it. If you're not familiar with how to do this, we could go ahead and just try this right now. I'm gonna go ahead, add a plane. I'm gonna go into edit mode, click on subdivide, and I'm gonna just keep doing this until I get the amount of detail I want. You could open this menu by pressing W. Again, this is not really a tutorial for beginners. It's pretty much for people who are already familiar with Blender. I'm just trying to show how you could use this add-on, which in itself is a little bit complicated, so just bear with me, please. Anyways, now we have our object. Let's make sure that we change it over here from simple to plane. Beautiful. And I'm gonna just reconnect it, just to make sure that everything is good to go. Alright, so the way GrowthNodes work is that you have an object and you keep applying displacement on this object. What I mean by that is, for instance, in this scenario, if I go ahead, get a displacement, let's get Cloud Twirl. What we had, let's set this to be 0.1, and let's set this to be 0. Let's set this to be 0 over here too. If I keep duplicating this on top of itself, we are going to get some mesh that resembles some sort of growth processes. In this scenario, this could be fungus growth or cellular deformation, whatever you want to call it. But as I mentioned earlier in this overview, the purpose is mainly at exploration. if you want something that is actually scientifically accurate, you should look into Ready, which is a cross-platform implementation of various reaction diffusion systems. But the very cool thing about Ready is that you could write OpenCL scripts, and everything's computed on the GPU. It is super fast. All in all, it gives you a lot of functionality that you would not have access to in Blender. But for what it's worth, you could do similar stuff in Blender, mostly aimed at the surface of objects. Anyways, let's just go ahead and see what we can do. So I have my object set, I have my texture set, and I have my displace node. Let's go ahead and say, let's go ahead and bake the node tree. So it's going to take a few moments, and we're going to end up with something like this. This is not really that impressive. It's essentially what we got from applying different displacement modifiers, but if you think about it for a quick second, we were able to add essentially 10 modifiers on top of each other using only 3 nodes in a fraction of a minute. I would say probably 10-12 seconds. And the other cool thing about this is that this is actually non-destructive. So at any point, I can go back to my initial geometry that I had. And you might be wondering, how is this working? Basically, it's a trick that we are doing using shape keys. So every displacement is applied as a shape key. Now, if I set everything to be 1, then what we could do is we could see that, hey, this is the first displacement, this is the second one, this is the third one, this is the fourth, fifth, and so on. Now, one of the more interesting aspects of this approach is that Blender has this really cool feature that you don't need to have shape keys relative to each other. What you could do is actually interpolate between the shape keys. So as you can see right now, the shape keys panel is telling me that at 180 my last displacement is going to be applied. So what they mean by that is that if I change my evaluation time to 180, then I'm going to be getting that. If I change it to 160, I'm going to be getting displace 8. If I change it to 140, I'm going to be getting displace 7. Before I continue, let me increase the size of, yeah, I think that's good. Okay. One of the cool features is that I had to run the simulation only for 9 frames, but now what I can do is I can animate the simulation for how many frames I want to have. Let's actually make this very over exaggerated. Let's say we have 6,000 frames. So what I can do is I can add a keyframe for value of 0 at frame 1, or where am I? Am I at frame 9? Okay. Let's just go back to frame 1, add a keyframe at 0, and then let's go to frame 6,000 and add, what value was that? 180. So now what's going to happen is that 9 frames of simulation are going to be animated over 6,000 frames. You have a lot of fine-grained control over shape keys, which is essentially the simulation data. One of the problems with this approach is that we are going to get a lot of intersections. Dealing with intersections is something that's planned for the next release, in addition to a bunch of bug fixes, mesh sequence exporting. These are all planned for future release. But at the moment, GrowthNodes does not handle self-intersection. Also, in many occasions, many different situations, you're going to get these jittery, very rigid edges. And the way that I usually go about fixing those is that I add a corrective smooth. Make sure smooth type is set to length weight, and also apply only smooth, increase the factor, and you could also increase repeat. And you could see the difference here. It actually makes the geometry look much nicer, and as usual we could observe how the simulation is occurring. So this was the simplest demonstration of GrowthNodes, but we're gonna go into more detail in this tutorial. One of the things I want to show you is how we could make the simulation frame dependent, so that these variables are actually changing based on the time that we have. So in order to do that, before I go ahead, let me remove all of our shape keys so that the geometry is clean. Also, I'm gonna hide these. If you're simulating an object with a lot of geometry, make sure that corrective smooth is not visible, because if it is, the simulation time is actually going to increase. Alright, let's see how we are going to approach this. Let me do this. Let's add another texture. I'm going to select wood for my other texture, and basically it looks like this. So nothing special. We have another node in the texture category called texture alternator, and basically what texture alternator does is that based on a condition, it is able to change the texture. So if the condition is false, it's going to use the second slot, and if the condition is true, it is going to use the first socket. This kind of bothers me, texture preview, but it's not working right now because this is working over here. I wonder if I change it. Okay. It's tricky, but if you're ever in doubt what's going on, you can always look at the title of the texture and just find it over here in the texture tab and see what it actually looks like. So now let's see how we can change this condition automatically. So from the integer menu, you could find this node called frame, and as you can see, while sliding the marker on the timeline, the frame number is also changing as well. Now let's say I want to use the cloud texture for even frames and the wood texture for the odd ones. So what I could do is I could come here and do an integer math. I'm going to say that I want the mod operation, and I could actually connect an integer to Boolean, and as you can see, it is automatically translated for me. So 0 is translated into false. So on even frames, we're using wood, and 1 is translated to true. So we are using the clouds texture. I could go ahead and actually plug this into my strength or mid-level, but I'm not going to do that right now. And even though this is not a tutorial meant for beginners, over here this mod operation is essentially just seeing if our frame is even or odd. So I'm looking at the remainder of dividing the frame by the number 2. So if I divide an odd number by 2, my remainder is going to be 1, and if I divide an even number by 2, my remainder is going to be 0. And that's what's happening. Nothing too complicated. Another way to look at it is, if I change this to 5, for instance, I'm gonna get true for 4 frames in a row, and then every frame that is divisible by 5 without having any remainders, so it is divisible by 5, is going to make the displacement use the wood texture. And if the frame is not divisible by 5, it is going to use the first one. So the conversion from integer or even float to Boolean happens in a way that if it's 0, it's going to be false. If it's anything other than 0, it's going to be true. If you're familiar with programming languages, this should not be a surprise. Let's change this back to 2. Let's make sure that our frame goes from 1 to 10. Cloud twirl, wood, plane, and we have frame 0 and 1. Okay, let's give this a try. Also, let me duplicate this object, which is going to be called plane 001. For plane 001, I am going to remove all of my shape keys, and in this scenario, let's go back and plug in cloud twirl just so we can compare what difference was introduced really by just alternating between the textures. So I'm gonna bake the simulation again for this one over here. Let's go to the modifiers panel and apply the modifier for both of these. So also to mention, okay, before I move on, I want to mention that the panels that are available here are also available in the 3D view. So just keep that in mind. We could drag this down for now and just compare the results of these two simulations. So I'm going to shade both of these smooth. Let's make both of them. Let's make both of these be not relative, and let's change this to 250, and let's just compare these. And see how the animation process for simulation is working out. So as you can see, the wood texture is showing up over here, and we have this growth process that slowly switches back and forth between the cloud texture and the wood texture. if I go directly into top view, you could see that just a minor change, which is alternating the textures between even and odd frames, could drastically change the result of simulation. And that's what I mean by saying that this add-on is mainly for exploration. The outcome of your node trees are so sensitive to the values and the parameters and the textures that you're going to use that there's really no way to have a simulation that is exactly what you want. However, with Ready, you have that mathematical precision, which is not really present in GrowthNodes. But I see GrowthNodes being used extensively for content generation, to create terrain, to create different objects, let's say to quickly come up with assets for a VR experience that immerses the viewer in your cellular, in the realm of cellular interactions, and you could go from microscopic to macroscopic. You could simulate planets, or you could simulate tiny little organisms in your body and whatnot. And if you want to see some of the examples, just head back to the GitHub page. There's a lot of different GIFs that show what is actually possible with GrowthNodes, and we're actually going to dive more into that right now. So let's continue our tutorial. I'm just going to duplicate this for now. Just so you see, let me move him to the second layer. And let's see, let me clear the keyframe, set it to be 0, 0, clear, and let me also delete all the shape keys so our object is fresh. Oh, that's why this was not working. So it gets a little bit tricky. If you notice, I removed the keyframe over here and it was still showing up over there. That's because the object data is only showing the objects that are referenced inside my node tree. And in this scenario, I'm referencing plane 001, but that was just moved to layer 2, and what I have selected here is simply plane. So keep that in mind. I'll probably change the behavior of this for next release as well. If you remember, I said we could also change the value of the displacement strength and the mid-level. And let's actually go ahead and do that in this tutorial, in this section of the tutorial. And our aim is going to be creating some sort of growth process on this that resembles pulsing, similar to looking at someone's neck and observing how the surface on top of their artery is pulsing. So we're gonna go ahead and create something that's similar to that. Let's see. So let's go back to our texture alternator. Let's keep that to be wood, and let's select something different. Let's go with marble terrain. So just to show you what that looks like, something like this. Blender gives a lot of different options for each texture that you could play with. By default, marble looks nothing like what I just showed you, but if you go a little further and start playing with these different properties, you're gonna get a texture that is going to be unique. Alright, let's see. So I have a texture alternator here, and let's close that for now. Before I do that, just to remind you again, For even frames, we're going to use wood, and for odd frames, we're going to use marble train, right? So yeah, let's do this. Let's say odd and even. Alright, now we know what's going on. So how could we go about changing this? We already have something like this, which is telling us if the frame is even or odd. Let's go ahead. So the value of strength here is pretty small. Let's see what we could do. Let's go ahead and get a math node. So you could easily convert back and forth between integers, float, and boolean. Float sockets are designated with the color orange, integer with green, and booleans with this purple bluish color. I'm gonna get the results of this odd evenness, plug it back into the float math. Now it's activated. Let's go ahead and maybe divide this by 20. Okay, so if my frame is even, this is going to give me 0. If it's odd, it's going to give me 0.05. Let's go ahead and let's go ahead and duplicate this. Set this to be multiply. Get this value, multiply it again to get 0.5, and I'm going to plug this into my mid-level. So what happens? On even frames, my mid-level is 0. On odd frames, my mid-level is 0.5. Okay, so where are we at? I'm gonna duplicate this float math. Go ahead and get this divided by 100. Duplicate this again. Put it into the bottom one. Let me change this to plus, and also get this guy. So as you can see, the values are being updated here based on the frame that I'm on. In this scenario, 168. But for this simulation, we will never get to frame 168. In fact, the simulation is going from 1 to frame 10. So let's check the values that we get in this scenario, going from frame 1 to 10. What's happening to my mid-level is that it is simply switching back and forth between 0 and 0.5. On the other hand, what's happening to strength is that it is slowly increasing as I keep going up my frames. Now we're on 0.3, then we are on 0.4, but the other thing to note is that the strength is changing, is increasing in value differently for even and odd frames. So frame 1, my value was 0.06, and frame 3, my value is 0.08. Frame 2, my value is 0.02, which is actually less than 0.06. So odd frames have a higher strength than even frames. And what that means is we are going to be displacing the surface of this object more by the marble texture than we are going to do it by the wood. Because if I move these down a little bit, we can see that on even frames we have wood, on odd frames we have marble, and similarly even frames and odd frames have different values. the relation is that what you should note here is that even frames have less displacement than odd frames, and they also have different textures. Anyways, let's go ahead, bake this, and see what we're gonna get. Alright, so what had just happened? If you remember, we started this section trying to replicate something that looks similar to pulsing. So let's actually animate this and see how close we were to replicating such a thing. Oh, should have set that to 180. If you want to know the exact correct values at which each of these shape keys is triggered, just look. If you disable relative, it's going to tell you what you have to put for evaluate time. So fixing that, we could look at this again, and if I look at this from sides, you could see that we are getting something similar to a pulsing. However, we are also applying the growth on this object. And if you want to compare this to what we had, let me just go back to. So using different textures, we are getting very different simulation results. One of the things we could also try, so now that you know the results are going to be very different, I'm just going to go ahead and delete those two other objects. I'm also going to go ahead and delete all the shapes for that one, and let's just only use marble terrain. Should I change? Let's keep the values the same. Alright, so we got something pretty similar. Let's reduce this a little bit. So just as a reminder, corrective smooth can dramatically change how the object looks. So what's happening here? As you can see, we are simulating something that resembles these different plateaus, and then it starts curling way too much and changing more than expected. But the reason why I was showing you this is that if I change this back to 5, you have a lot of control. The cool thing about how GrowthNodes stores the big data is that if I duplicate this object right now, from the same baked information, now maybe even let's change this to 1. The same baked data is giving me 2 very different objects. And the reason for this is, again, we have very fine control over the simulation data. Essentially, what we're seeing over here on the right is an underlying simulation step for the object on the left, but at any point we could use only the frame that we want, or we could animate these, or we could even change them in terms of the value that they represent. And you might be wondering, okay, what do you mean by that? So let's change all these guys to 1, and let's hide all of them. So this is the initial one, this is okay. So frame 2 is pretty good. This is what I have for the second displacement that's happening. I can change this max value to 5, and now I'm getting a very different object. And just to revert this back, let's put this back to 1. So these are literally duplicates of the same object, but you can see that the information that is baked by the simulation process and GrowthNodes allows you to derive so many different states for the same surface, which is quite interesting. In the next tutorial, in the next section, what we are going to do is we are going to get rid of all of these guys. Let's put everything back in the center, and let's go ahead and add a round cube. Let's go to edit mode and subdivide this a few times. Let's subdivide smooth. I don't know why the birds are singing right now. It's so late at night, but I guess I don't let them go to sleep. So let's just use the same node tree that we had without changing anything for our cube, or I should say sphere in this scenario. Let's go ahead and bake it again from frame 1 to 10. At the moment, GrowthNodes does not really show any progress bar, and what we have ended up with is this really crazy looking thing. The edges are all intersecting, doesn't look nice at all, but as I mentioned earlier, you could always fix this with the corrective smooth modifier. Let's go back and let's see what is happening. So you see, initially our simulation is replicating something that looks fairly like a planet. We have all these different plateaus and crevices, and you go ahead and use this. As the simulation progresses, we can see that this starts to diverge from what it initially looked like, and let's actually animate this from frame 1 to 200. Last one's going to be 180, and let's see if we do get that pulsing effect that we were looking for. Yeah, it almost looks like it's a breathing sphere. It's a breathing planet, or whatever you want to call it. Again, as a reminder, exploration is the primary focus of this add-on. Alright, so what we have over here is an object that has a bunch of different vertex groups. If I go to weight paint, you could see that, for instance, I have something like this. I have another vertex group that looks similar to that, and I have another one that just wraps around the sphere. Let's go into our node tree, select everything, and we can remove it. For now, what is this object called? Sphere? Easy enough. Let's change the texture. Let's keep that as marble train. I'm gonna duplicate this. For marble train, let's select group 1. For this one, let's select group 2. Let's select group 3 for the other displaced node. For group 2, let's select Voronoi. For group 3, let's select distorted noise. These are some textures that I prepared in advance for this tutorial. Voronoi looks something similar to that. These are the precise parameters if you're interested to replicate this. Distorted noise, that's what we got. Alright, let's go ahead and bake this node tree from frame 1 to 10. It's going to take a while because essentially we are applying a lot of displacement. Oh, so what happened? What happened? Let me remove all the shape keys. What I forgot to do was change the strength for these displace nodes. So let's go ahead and change those right now. Let's set this to 0.08. For vertex group 2, let's set it to 0.24, and for vertex group 1, let's set it to 0.04. Usually for objects at this scale, a value less than 0.4, 0.3 works really well. It also depends on your texture. Just play around with these values. Usually baking stuff doesn't really take that long, so go ahead and play with the parameters. Let's bake this again and see what's gonna happen. Alright, as usual, looking crazy, but let's go ahead and start applying our corrective smooths. Actually, you could see one of the issues that came up here. Our mid-levels are set to half. What I'm gonna do is duplicate this object, just leave it to the side. I'm gonna go back here, disable all these corrective smooths, remove all of these again, and set all of my mid-levels to 0, bake, and see what's gonna happen and how different it's going to look from the one that we have on the left. So first thing to notice is that our normals are correct, unlike the other one that we have over here. A trick to fixing that is go to the Object Data tab and select double-sided. for your normals, and it should take care of it. But essentially, the objects that we ended up with are different as well. So something to keep in mind, this mid-level actually affects the final product that you're going to get. My first corrective smooth is targeting group 1, the second one is targeting group 2, and the third one is targeting group 3. But this is very redundant because right now what's going on is that I have the same values for all of them. So let's try something else. What if I remove the vertex group? So let's do that. Let's just have one corrective smooth. Now, what has happened? If we go into weight paint, we can actually see that for each of our vertex group, we have a different growth process based on the texture that we've selected happening. And as you keep scrolling through these vertex groups, it becomes pretty obvious that the growth process is indeed respecting the vertex group parameter. So for instance, we have a very smooth surface over there, and that is because none of our vertex groups are targeting that area. So that's how you can use vertex groups. Before we finish this section, let's just animate this and see what it looks like. One thing to notice is that prior to this, all of our values were 0 to 180. Now we actually have 540, and that's because we are using 3 displacements. So 3 times 180, 540. Set that to be 540, and let's give this a try. Pretty cool. So for the next tutorial, we are going to be looking into the topology features of GrowthNodes. So bear with me. So let's go ahead and add another round cube. We're not going to be concerned with the detail of the object that much. Keep in mind that topology features are destructive. That means they're going to change the geometry of your object, and essentially you cannot undo that. However, for the next release, I'm going to implement mesh sequence exporting, which means you're going to be able to have access to each frame of, or to each, to the geometry at each simulation step. That's the best way to put it. For this one, let's go ahead and try to simulate something that looks similar to growth of crystals, let's say, or maybe corals. Corals sounds better. So let's get our workspace right. Let's select the correct object. Doesn't have any vertex groups. Let's set this to be distorted noise. Now let's go ahead and add a frame node, and let's go and do an integer compare, and let's say we are interested in frames that are less than 3. Okay, and let's see where we're gonna go from there. So let's start with sharp faces, and you might be wondering, what does this do? Right now what I have is top and bottom. Let's change this to be only bottom, and also let's change the value of our weight to be that of integer compared. So what's gonna happen? What is this doing? If our frame is less than 3, we're gonna get a weight of 1, and if our frame is bigger than 3, we're gonna get a weight of 0. What sharp faces does is that it's going to select faces based on an angle. Let's say we're interested in an angle of 60 degrees. This is the angle that the normal of the face is going to make with the z-axis. So what do we mean by that? In this scenario, if I want to draw this properly, let's see. Let's go ahead and select cursor. So the normal of that face is going to be something like that. The normal of that face is going to be something like this. This face is going to have a normal that's probably looking like that. And if I go ahead and create another node that if I go ahead and create sorry, not another node. If I go ahead and create a line that that shows the z-axis, if that is the z-axis, then we are interested in the angle that this blue line is making with the z-axis. So in this scenario, that's going to be my z-axis. Now what is happening is that we are going to target all the faces that make an angle of up to 60 degrees with the z-axis. So all of these are going to be selected, and we're probably going to go ahead and select some of the faces that are in this upper hemisphere. If we were to select to check the bottom feature as well, we would also be targeting these faces in the bottom hemisphere. So let's see. Now we're going to target these sharp faces, and what's going to happen if I set this to be from frame 1 to 2 and just bake this really quick, and let's not even have displacement happening. We have this vertex group now called sharp faces, and if we look at it, you could see that all these faces that make an angle of up to 60 degrees with the z-axis are selected. If I select bottom, go back to object mode, bake again, you could see that both the bottom and the top faces are selected. So let's remove this right now. Let's set this back to what we had, and let's see what we can do once we have these faces. So GrowthNodes allows you to subdivide an object, either the entire object, or you could actually subdivide only the vertex groups. In this scenario, let's go ahead and subdivide the vertex group that we were given by this sharp faces node, and I'm going to keep the cut count to something that is actually sane, which is 1. Every time you grow, every time you increment this number by 1, so if I change this to 2, let's actually test this before I attempt to misinform you. So subdivide, we have 4, subdivide, now we have 16. Yep. So every time you increase this number by 1, the time it takes to process the simulation increases by 4. And that's going to happen for every frame, every discrete step in the simulation. So keep that in mind. So now we are gonna go ahead and subdivide this. Let's do something else as well. Let's go ahead and after we subdivide this, let's tell GrowthNodes to also displace the object. Alright, so let's see. Everything looks good. Let's change this back to 0.1. And let's change this also back to 10. Or 10 might be too much. Let's try 8. Oh, fake node tree. Cube. Okay. Oh, I think the object needs to be selected. That is probably the issue. Let's try it again. Yep. So make sure you select the object. Alright, we end up with something crazy looking like that. But if we go ahead and add our good old corrective smooth friend, let's set this to be length weight and only smooth. If I look at our object data, we have something that resembles growth processes of either crystals or it could be corals. If you start increasing corrective smooth, as you can see, corrective smooth is going to affect these areas too. But nonetheless, we get interesting result. What is more important though is this is something that we initially started with. But now if we go into edit mode and go back to basis, you could see that GrowthNodes was smart enough to add geometry only to places that we needed, which is top faces that make an angle of up to 60 degrees with the z-axis. So in a way, you're able to define the geometry that you are targeting. In fact, we call this targeted geometry manipulation, and we're going to dive a little bit more deeper into it. Let's go ahead and remove this object, and let's add another one just like it, and let's select it in our node tree. And not always you have to end your node tree with a displaced node. So let's see what else we could do. Let's go ahead and add another geometry node, and let's go ahead with dissolve degenerate. What this does is essentially what you get in degenerate dissolve in edit mode. But let's actually see what it does over here. So let's hook up our object and let's actually get sharp faces from over here, plug it in, and let's set the value to be 0.01. What this does is that it's gonna find those vertices that are closer to each other than this value, and it's gonna merge them, collapse them into a single vertex. Also, another thing that I would want to try is actually plugging sharp faces to the displace modifier. Alright, let's try this. let me duplicate this object, and let me create one as well. Should have done that earlier. Round cube 12. What did we have before this? So it just didn't have this dissolve degenerate, and that was not plugged in. Okay, so let's just fake this as well. So as you can see, the results are different, like expected. I'm gonna apply the length weight. I'm gonna select my other object and copy the modifiers. Let's go ahead and play with this. Let's open our shape keys, change from relative, relative I, then 140, which is what we're told over here, and 140 in our final frame. So let me select both of these objects and make them smooth. And that's what we get. It's actually a pretty cool result. As I mentioned earlier, what you could do, I don't remember which is which right now anymore. Let's just delete this one. But before I fully do that, just to remind you, as you can see, this object on the left is resembling that of the one on the right. However, what's happening is that this dissolve node is collapsing those sharp edges together. Is collapsing those close vertices together. So all the vertices that were over here at the top are now collapsed into way less on the left. Confusing myself, changing the viewport too much. Also, the other thing that I wanted to remind you of again is that we could increase the value way more, right? And now, I guess it doesn't really affect. But yeah. Okay, what else do we have? Alright, with this I'm going to conclude this overview. I hope that you find it useful. If you have any issues, I believe clicking on report a bug will take you to the issues section on GitHub, or just directly go to the issues section on GitHub. Thank you for your attention, and good luck.